Welcome to Spring Lib.
We're told the rate at which photosynthesis takes place for a species of phytoplankton is modeled by the function p equals 100 I over I squared plus I plus 4, where I is the light intensity measured in thousands of foot candles. We're asked for what light intensity p is a maximum. To answer this question, we'll want to differentiate p with respect to I, then find critical values. So we have the derivative of p with respect to I, p prime of I. This is I squared plus I plus 4, bottom times the derivative of the top, 100, minus the top 100I times the derivative of the bottom, 2I plus 1, all over the bottom I squared plus I plus 4 squared. Now we can factor out 100 from the top. And so this is equal to 100 times, and then we have I squared minus 2I squared is negative I squared. We have positive I minus I is 0I, and then plus 4 all over I squared plus I plus 4 squared. And we can factor this as negative 100 times I minus 2 times I plus 2 over I squared plus I plus 4 squared. If we set this equal to 0, well, this gives us the critical values I equals plus or minus 2. Of course, you can't really have a negative light intensity, so I is just positive 2. This is our only critical value. Now, notice that the rate p, this approaches 0 as the intensity I approaches infinity. So it follows that our function p has an absolute maximum on the interval 0 to infinity. So we simply have to test the value of p at 0. This is 0, and the value of p at 2. Now, the value of p at 2 is 200 over 4 plus 2 is 6 plus 4 is 10, which is 20. So clearly this is greater than 0, and therefore it follows that p has an absolute maximum value at I equals 2. And this is in thousands of foot candles.